With the very first lecture, we had a look at the concept called as the horizontal plane and the vertical plane, which is dividing the entire space into 4 quadrants, namely quadrant number 1, which is above horizontal plane and in front of vertical plane, quadrant number 2, which is above horizontal plane and behind vertical plane, quadrant number 3, which is below horizontal plane and behind vertical plane, whereas quadrant number 4, which is below horizontal plane and in front of vertical plane. Any object that we talk of, for which we are required to take the projections, the orthographic projections on the horizontal plane and on the vertical plane, we will be dropping perpendiculars from each of the point or each of the side or each surface to the horizontal plane and vertical plane, and those perpendiculars, wherever they intersect the horizontal plane, vertical plane, that will form the image. That is the projection, or what we call it as the front view if the projection is taken in the vertical plane, and if the projection is taken on the horizontal plane, it will be called as plan. Now here the sequence is the observer, then the object, and then the image that we will be getting. We are imagining over here that the object is placed in the first quadrant. We have also seen that the horizontal plane is going to get rotated about the XY line, and it is going to get coincided with the vertical plane, and ultimately the view that we obtain in the horizontal plane will be shifted below XY line, and the view which we obtain in the vertical plane will remain above XY line. Consider the different cases, that is, if the object is placed behind the vertical plane, that is in quadrant number 2. If the object is placed in quadrant number 2 and if we take the projections and if we can recall, then the front view will be above the XY line, that is the projection in vertical plane, whereas top view, which is going to be behind the vertical plane on the horizontal plane, and after horizontal plane getting rotated, that particular portion will coincide with the portion of the vertical plane which is above XY. And in this case, even the top view will be drawn above the XY line, and that both the views, that is front view as well as top view, will be above XY line, and there could be some confusion. Now, as I was telling you all these things, I am expecting that you could imagine that particular picture in front of you. Now, understanding the words over here will be a bit difficult task, because you will have to analyze or grasp every word, not the meaning of that particular word, but you will have to also get in front of you the particular image that I am talking of. You will have to have the horizontal planes and vertical planes in front of you, and you should be looking exactly at that quadrant which I am referring to. It could be first quadrant, second quadrant, third or fourth. You should also be imagining that the horizontal plane getting rotated, and then you should be conceptually thorough to imagine that both the views will go above XY line, or one view is above XY line and other view is below XY line. Of course, all this description will not be of much use unless you really are through with all these concepts. But as we call this particular engineering drawing as the language of engineers, probably our attempt will be to eliminate the use of English language and all this description for the communication between different engineers or designers. Instead of that, we will be drawing these views, and these views themselves will speak about their position, they will speak about their dimensions, they will speak about the details that they possess. Each surface, whether it is curved, plane, inclined, vertical, horizontal, all those edges as well as the points. Now, I will just show you pictorially as what I was mentioning. I was talking about the two planes, horizontal plane and vertical plane, and some figure like this, which we have already discussed. So this is vertical plane, this is horizontal plane. We have noted the intersection of these two as XY line. We have also said that this horizontal plane is going to get rotated after obtaining the projection on it. And if you just see the intermediate positions of this horizontal plane, it will get rotated, and at one time it is going to get coincided with the vertical plane. This could be the position. And so any view that is obtained over here on the horizontal plane will be shifted below XY. So if I just draw a figure like this, and I am just showing that this is vertical plane and this is horizontal plane as I have named it earlier. But remember that this is the portion of the horizontal plane which is in front of VP, whereas the portion of the horizontal plane which was behind VP has also been transferred and it is over here, if you can imagine it well. And the portion of the vertical plane which was below horizontal plane is still present, and it is this part. So suppose this is the portion of the vertical plane that we have which is above HP, then this is the portion which is below HP. Ultimately, XY line when you draw, then this region which is below XY line can be considered as portion of horizontal plane which is in front of vertical plane. Such a description we have already seen in the previous lecture. Or it could be considered as portion of vertical plane which is below horizontal plane, whereas the portion above XY line is portion of horizontal plane which is behind vertical plane, or it can be considered as portion of vertical plane which is above horizontal plane. Now, though I am drawing these lines, it doesn't mean that this right portion belongs to something and left portion. It is the entire region which is above XY line. This is below XY line. And this is below XY line. And with this information, we can probably proceed to the very first topic called as the projections of points. In projections of points, instead of considering any object, that is either a plane or a line or some solid, we will be talking simply about a single point which we will try and place in different quadrants. For example, say consider point P, which is say 20 above the horizontal plane and say 15 below or in front of the vertical plane. So it is 20 above horizontal plane and 15 in front of vertical plane. I can take the distances over here. Say this distance is 15 in front of vertical plane, and then I can draw a distance 20. Suppose this is 15, then this could be 20. This is point P. If you can imagine, then the projection of point P in vertical plane can be marked over here, and the projection of point P, this is projection which is taken perpendicular to the vertical plane, this angle is 90 degrees, and the projection of point P in horizontal plane will be this point P, whereas this will be named as P dash. Now when we open up this particular horizontal plane, then point P will get rotated and this line will simply coincide. This is how it gets rotated, and this will be point P. And ultimately, when we draw the projection of point P, we'll be drawing a line perpendicular to xy. Now this perpendicular line is actually the plane which comprises of small p, capital P, P dash, with which is perpendicular to horizontal plane as well as vertical plane. So this is actually a plane which is perpendicular to both HP and VP and is generally called as the projector. So projector is actually a plane. Projector is actually a plane which is perpendicular to HP as well as VP. And on this we can now mark the distances, that is, it is 20 above HP, named as the elevation, so will be always with dash, and 15 in front of VP. So it will be point P, small p. Of course, as you are drawing the projections, you are required to even show the dimensions appropriately with XY. Nobody is going to ask you any question on projections of points in your final exam. But remember that projections of points itself is forming the base for any solution in engineering drawing. So these will be the projections of point P. And observe that it is portion of vertical plane which is above HP, that's why elevation is above XY line. And it is the portion of horizontal plane which is below or in front of VP, which is this portion, so the plan is below XY line. This point P is in first quadrant. In description it was above HP and in front of VP. That was the total description. Suppose we imagine point Q, which is say 10 above HP and 30 behind VP. Then we might be having point Q here. Of course, how to see this particular part, how is it visible, that is not the current point of discussion. But you can very well see that Q is above HP, that way you can very well imagine, and is behind. So this particular projection that he is taking is on that vertical plane. So this point will be termed as Q dash, and this point is Q after dropping the projections. And then if we try to plot that point, we are required to have the projector for point Q. Q dash point is 10 above, because it is 10 above HP, and 30 behind VP, so point Q can be shown, because after rotation this portion is going to go up, so this Q point will get shifted and will be just above Q dash. It will occupy a position like this after rotation. And then show the dimensions. That is 10, and if possible 30 on the same side you can show. But this point Q, which is in the second quadrant, with the description that it is above HP and behind VP. So this was the projector plane for point Q. Point R, which is say 20 behind the vertical plane and 20 in front of vertical plane, suppose 20 behind vertical plane and 20 below horizontal plane, suppose. Say this is point R. Now to locate these points, actually the side view, that is if we look in this direction, will be very useful, because point P, which was 15 in front of and 20 above, can be located here in the side view. Whereas point Q, which is 10 above HP and 30 behind VP, is locatable over here. It was our coordinate system, but it is actually HP and VP which are seen. And point R that I am talking of is actually 20 behind VP and 20 below HP. This is point R. After rotation, this is going to be the elevation R dash, and this is plan R. This R plan is going to shift up, and it will be on the same projector, and you will find that projections of point R will be plan R and then elevation R dash. Both at a distance 20 that was given to us. So point R is in third quadrant with the description that it is below horizontal plane and behind vertical plane. That is our specification of quadrant 3. And then if we proceed further to one more point, say point S. Point S, I am going to define it in the fourth quadrant, that is in front of VP and below HP. Say it is 30 in front of VP and 20 below HP. This will be point S dash and this will be point S, and after rotation S point will just go below S dash. And so the projections of point S will come out to be it will be point S dash and point S. It is 20 below HP and 30 in front of VP, which is point S. So it is a specification of quadrant 4, that is below HP and in front of VP. Actually, these 4 points, if you can think of them correctly and draw their projections, everything else is going to be a very simple and straightforward task. This figure is of very importance as such, which is talking about all the quadrants. With this, we can prepare a table in which we will have description of each quadrant and where the view will go. So it is quadrant, then its specification, that is with respect to HP and with respect to VP, and also the position with respect to XY of the front view and top view. Such a table will be of very much use. Quadrant 1, specification is above HP and in front of VP. Front view will go above XY line and top view will go below XY line. Quadrant number 2 is the portion which is above horizontal plane but behind vertical plane, and so front view will be above XY and so is the top view. Quadrant 3, which is a portion below horizontal plane and behind vertical plane. In that case, front view will be below XY and top view will be above XY. And in quadrant number 4, the description is below HP and in front of VP. Front view will be below XY line and top view will be below XY line. If the problem is to be attempted in a mechanical way, then we can say that the wording which is above or below, they have their usual meaning even with respect to XY. But the wording in front of will lead to the view to be transferred below XY line, and wording behind will lead to the view to be placed above XY line. Whereas with respect to HP, the wording above and below, they will have their usual meaning and the positioning accordingly, that is above and below. Nothing very special about it, because you can always see that above means upward, below is down, and we also know that the distances from horizontal plane are reflected in the front view, which you can very well see here. Point P, which was defined as 20 above, now this was the distance of point P from horizontal plane given as 20, and this distance 20 is visible with P dash, that is elevation, that is the front view, and it was said that it is 15 in front of VP, and that distance 15 is visible with the top view. Same thing will hold good in all the cases, and so we can say that front view, which is also called as elevation, will show us distances from HP, whereas top view, also called as plan, will show us distances from vertical plane. And then this entire discussion will, I suppose, complete the projections of points part, because there is not going to be any independent question on it, but it should be possible for us to plot every point. As an exercise, we can try something like this. Say, find out the quadrant of all these points. Just tell the quadrant. Say I have point A dash, point A, then say B dash, B, then this is C dash, C, then this could be D as well as D dash, then this could be E as well as E dash, and then you can have, say, F and F dash. With respect to XY line, I am simply positioning different points. I am drawing the projectors. The distances are not important because we are required to simply find out the quadrants. Now you will have to locate. The particular table is to be used other way around. We have got A dash above XY line and A below XY line. Now A dash above XY line and A below XY line simply tells us that front view is above XY line, top view is below XY line. For top view, the description will be distance from VP, and distance from VP or position with respect to VP is in front of, whereas elevation directly tells us as whether it is above or below. So ultimately this description will go as the point is above HP and the point is in front of VP, and you can say that point A is in first quadrant. If you look at point B, then elevation is below XY line, that means point is below HP, and plan is also below XY line, that is by B point, that is point is in front of VP. So ultimately the description is point is below HP and in front of VP. The point will belong to the fourth quadrant. Point C has its plan above XY line, which means that it is behind VP, and its elevation is on XY, and if elevation is on XY, the point will belong to horizontal plane. So it is in HP, but is going to be behind VP. Point B, you will find that elevation is on XY, plan is on XY, and that's why point will belong to horizontal plane as well as vertical plane, that is the intersection of both the planes, XY line itself. Point E has got its elevation above XY line, so the point is above HP, and its plan is also above XY line, though the distances are same. Plan position is above XY line, that means the point is behind VP. So it is above HP and behind VP. The point will belong to quadrant number 2. And in the last case, elevation is below XY line, so point is below HP, and plan is above XY line, so the point is behind VP. So ultimately it is below HP and behind VP. It will be quadrant number 4. It will be quadrant number 3. It is below HP and behind VP. And so from the description or the positions of elevation and plan, we can make out the quadrant of a particular point. Let us revisit all these figures one by one. That is first figure where we have shown all the points. Figure number 2 where we have actually marked the projections. This is called as projections of points with dimensions. This was the conclusion that we have drawn. And then the same information can be used in reverse. Figure number 4. Revisiting these figures one by one, you can always recapture the concept of projections of points. After projections of points, we will do one exercise related to projections of lines. But we will not be interpreting the given figure as the projection of line, or we don't want to describe the line with the dimensions or the angles, anything like that. But we are interested in just checking as through which quadrants this particular line is passing. Line by definition is the collection of points which satisfy a particular condition. Now, if we draw, say, projection of one line, that is the projections of end points of that particular line are actually drawn and are connected. Suppose I name this as the elevation of line AB, A dash B dash, and this is plan of line AB. These will form the projections of a line AB. And then we check each and every point on it. Point A is above horizontal plane and in front of vertical plane, or you can always remember that elevation above XY, plan below XY, point will belong to first quadrant. Another description that I am giving you over here is elevation above XY line, plan below XY line, point will belong to first quadrant. Elevation above XY line and plan is also above XY line, that is both above, point will belong to second quadrant. Elevation below XY line and plan above XY line, the point will belong to third quadrant. And then elevation below XY line and plan also is below XY line, point will belong to fourth quadrant. Ultimately we say that both above XY, it is second quadrant, both below XY line, it is fourth quadrant. And then when the plan and elevation are on the opposite sides, it could be quadrant 1 or quadrant 3. This itself actually is forming the base for something called as first angle method of projection. First angle method of projection and third angle method of projection. Because these are the two quadrants for which the views are separated. Views are separated by XY line. And so we say that first angle method of projection with respect to XY line, you will have elevation above XY line and plan below XY line. Whereas in case of third angle method of projection, we will have plan above XY line and elevation below XY line. Of course, the conventions which are used are quite different. Like in case of first quadrant object, the object which is placed in the first quadrant, whatever is the object, say, whose projection on XY can be shown like this, and its projection on vertical plane can also be shown. And then when we open it up, you will get a view like elevation is above XY line and plan is somewhere over here below XY, or first angle. But the sequence, if you see, it is going to be the observer, object and image. For first angle method of projection, it will be observer looking at the object to get the image. It is as if the shadow is taken on the particular plane. And so, when you look from top to get the top view, this figure will act as the object and this will be the image. So this particular edge is visible, yes. If the same object would have been viewed from this side, you could not see the particular edge. You can observe it from here. Looking it from top only, you can see the edge. If you look at the object from bottom, this particular edge will not be visible. So the sequence in the first angle is observer, object and image. Whereas in case of third angle method of projection, when we have the object say in this manner, say the same object, but then it is placed in the third quadrant, that means it is below the horizontal plane and behind the vertical plane. Now to obtain the projection of this particular object, I will have to consider that the vertical plane is a transparent one. Then and then only I can actually take the projection of the particular object. I am to project it on vertical plane, that's why this particular plane should be a transparent one, and we are still looking from the same direction. In this case, we will have a sequence like observer, you have object on the other side, and in between you have the plane on which you are going to draw the image. So the direction of viewing, it is on the same side you will be having the image. Whereas here, in first quadrant, it will be on the opposite side you will be getting the image. Observer and image are separated by the object. Whereas over there, in the third quadrant, it is observer and object are separated by the image. Now the convention that we usually draw for the first angle method of projection is related to some object which is a frustum of a cone. We already know what the cone is. This is a conical shape. I am talking about a solid. Now suppose I cut it horizontally, then it will turn out to be an object like this. This is the object. The peculiar thing about this object is, if you look at it from top, then what you can see is the smaller circle of the top as well as the larger circle of the bottom. This is how you can get the view of that particular object. So we will be actually making use of the view in one particular direction, because if I look at it from the other direction, then probably I cannot see that smaller circle. It will be only the larger circle that will be visible. If I look at it from bottom, then the view will be, the bottom circle will be seen fully and the circle at the top is not visible, it is hidden, so will be shown by a dotted line. And so to draw the convention as whether the projections are drawn by first angle method of projection or third angle method of projection, we actually make use of this object, and then we will be drawing a convention in this manner. This is one view, which is the front view of it. And then we will be looking from the smaller side. Now this particular figure that you have drawn, front view, will act as object, and this is the direction of viewing. Observer will be always viewing from the smaller side. If we consider first angle method of projection, then observer, this view acts as object then the image will be drawn on the opposite side. It will be the first angle method of projection. And if the image is drawn on the same side, it will be the third angle method of projection. So we have observer, we have the object, and then see the conventions. So the object, observer is looking from this side and the image is obtained on the other side. This is going to be the convention that we will be using for indicating that it is first angle method of projection. And for third angle method of projection, we will be having the object, we will be looking from this side, and the view also will be drawn on the same side, that was on the transparent plane. See, we don't have to even write the words, even the wording is not required. If you simply draw it this way, it will be the third angle method of projection, and this is first angle method of projection. Only this symbol will indicate as by which angle you are going to draw the views. There is nothing like second angle or fourth angle. So only two quadrants where we can place the object, that is the first quadrant and third quadrant. But in third quadrant, as I have shown you the object, it rather appears to be funny, that as if the object is hanging in space. And that's why in third angle we also make use of one more plane, imaginary plane, called as a ground plane. And so whenever there is a reference of the word ground, object is resting on ground, some edge is on ground, we say that the particular problem should be solved by the third angle method of projection. And whenever it is mentioned that it is in HP, then obviously the problem should be solved by the first angle method of projection. This is the convention that we will always follow. In the very first sheet you must have drawn this particular symbol and also must have written below it as first angle method of projection, and for this you must have written below it as third angle method of projection. Of course this wording, as I have told you, is not required. Conventions which we might use for drawing this object, the dimensions, those can be decided. Actually this diameter is taken as 10, or this diameter can be taken as 20, this could be 30, and the distance between the two top and bottom surfaces can also be taken as same as this, that is 30. So this could be 20, 30, 20, but that is just a convention, it is not a full and final thing. We want such a shape, such a figure to be seen to indicate the method of projection. Going back to our previous discussion, as given the elevation and plan of a particular line, to decide as through which quadrants that particular line is passing. Remember, for projections of lines, projections of planes, unless there is a wording like resting on ground, but so far as lines are concerned, this concept never comes into picture, and all the lines problems are solved in the pure form, most pure form, that is references are taken with respect to HP and VP. There will not be any mention of ground. From planes problem, probably we will have to decide as what should be the method of projection, first angle or third angle. So in lines we will not be having any such thing directly coming into picture. From planes onwards we will be discussing it in more details. Now suppose we are given projections of some line, which are like this. Say line C dash D dash, its elevation, plan is CD XY. Now in the previous case, for every point on this particular line which is going to have its elevation and plan on the same projector, all the elevations are above XY line, all the plans are below XY line. This particular line will belong to first quadrant fully. Here you can observe that point C is in first quadrant. If I consider point which is adjacent to C somewhere here, another projector, then this is elevation, this is plan, this point is still belonging to the first quadrant. And we continue choosing the points and all of them turn out to be in first quadrant till I get a point whose elevation is on XY and plan is below XY. Now such a point is termed as point in HP and plan is below XY, so it is in front of VP. A little imagination will help you as where the line or how the line is passing. It comes from the first quadrant and hits the horizontal plane. From first quadrant, if you hit horizontal plane, you will be obviously entering into the fourth quadrant. Observe that from first quadrant, this is horizontal plane, this is vertical plane, this is second quadrant, third quadrant, fourth quadrant. If you start from first quadrant and hit horizontal plane first, you will be obviously entering into the fourth quadrant. So here you can observe that any point that you consider after that has got its plan and elevation below XY line. The line comes from first quadrant and enters into the fourth quadrant. Consider another line. Say A, B, A dash, B dash. We find that point A has elevation below XY line, plan above XY line. Point will belong to third quadrant and successively all these points will have elevation below XY, plan above XY. They belong to third quadrant and we reach a point whose elevation is on XY. So point is in HP and its plan is above XY line, that is it is behind VP. Little imagination will show us that from third quadrant you are hitting horizontal plane, you must be entering the region which will belong to the second quadrant. From third quadrant, when you reach or when you hit HP, horizontal plane, you will be obviously entering the region of second quadrant. We can just confirm it. Yes, I have elevation as well as plan. I have elevation as well as plan both above XY line, and the same thing continues till I get a point whose plan is on XY line. So point is in VP and its elevation is above XY line, so we say in VP above HP. So we have already crossed horizontal plane, now we are crossing vertical plane, so obviously you will be entering into the first quadrant and you can confirm that these points, they belong to the first quadrant. So this is the region of third quadrant. Then there is some portion in second quadrant and line enters into the first quadrant. So simply by having the projections of lines, we can determine as through which quadrants the particular line is passing. Say one more example. Say P dash, Q dash, P, Q. Point P belongs to fourth quadrant. Point Q belongs to second quadrant. Both below is fourth quadrant. Both above is second quadrant. So all these points, they belong to fourth quadrant till we get a point which is in HP, because elevation is on XY and in front of VP. That means from fourth quadrant you are hitting the horizontal plane first. That means you will be having some portion which is belonging to the first quadrant, obviously elevation above, plan below first quadrant, and then we get a point on plan which is on XY. So this is going to be a point in VP and above HP. And so the line passes from fourth to through first to the second quadrant. As an exercise, you can try these lines and determine their quadrants. This is problem number 1. Problem number 2. And problem number 3. Try these 3 problems and find the quadrants through which the line is passing. You should be drawing a figure which looks similar to this. Though the dimensions are not given, these problems are solvable. We'll be helping you to actually imagine all the problems or all the types of points which we will come across. Those will be the points which will belong to any of the quadrant or any of the reference plane.